All right, this is chapter 3, which is logic. And you're going to find a lot of similarities to what we did in chapter 2 with sets. In fact, we're going to have some of the same properties. We have just slightly different symbols. Now, sections 3.1 and 3.2 are a lot of definitions. Once we get into 3.3, you're going to see a lot of applications for this. So you just need to have a bit of patience as we build up the skills we need to get to that level. Okay, so 3.1 is statements, negations, and quantified statements. Some definitions. A statement is a sentence that is either true or false, but not both simultaneously. So things that would not be a statement would be an opinion, because it might be true, it might be false, or you can't really tell. Direct order, sit down, is not a statement because it's not true or false. We do not need to know whether or not a statement is true or if it is false. We don't have to know that, as long as it's clearly one of the two. It's either true or it is false, and it cannot be both. Okay? For example, there is an exoplanet in the Andromeda Galaxy where the inhabitants breathe only watermelon milkshakes. That is a statement. It's probably false, but we don't know for sure. It is either true or false. We don't need to search every exoplanet to be sure of that much. We just know it's true or false, and that's enough for us right now for it to be a statement. So again, examples of things that are not statements: opinions, questions, or commands. In symbolic logic, which is what mainly we're going to be dealing with, we use lowercase letters, usually P, Q, and R, and if we have a really complex one, we'll use S, to represent these statements. So for example, what you might see is something like this. For statement P, says all dogs are animals. Statement Q, Fred is a dog. Now both of these are statements because either all dogs are animals or all dogs are not animals. It's either true or it's false. And Fred is either a dog or it's not a dog. Okay, so it's either true or false. It is definitely statements. One of the things we're going to be dealing with a lot are negations of those statements. This is kind of equivalent to the idea of a complement when we were dealing with sets. Remember, a complement was like if we're the complement of set A, we were talking about everything that is not set A. For the negation of a statement, we're looking for exactly the opposite truth value of the statement we are given. Now, usually, the symbol we use for negation, if we're talking about symbolic logic, is the tilde. Okay, we use it for not. So if we're talking about this, you're going to see not P. Okay? And when we're negating something in English, usually we get to just add not, the word not, to the statement somewhere in there. All right, so let's look at an example problem. We are given the statements P, Q, and R here. We are asked to write the negation of each one and then represent it with symbols. Okay, so starting off with P. Listening to classical music makes infants smarter. Okay, if we want to completely negate this, we're going to add not in there somewhere. So the negation of P, which I'll go ahead and write symbolically, the negation of P would be listening to classical music does not make infants smarter. Okay, now let's look at not Q. Subliminal advertising makes you buy things. Not Q, let's add not in here somewhere. Subliminal advertising does not make you buy things. Okay, and then R, humans and bananas do not share approximately 60% of the same DNA structure. Now this one is a little bit different because we already have the word not in there. So if we're making the negation of something that doesn't have not by adding not, if we're having not in the problem already, we just take it away. So not are would be humans and bananas share, we don't need the do not anymore, and then the rest of it. Okay.